Hello there, it's Jay here from Jay's Vintage Junk, and today thought we'd have another go at this. This is that Defiant reel-to-reel tape recorder. I picked this up at a car boot sale, I think it was last year actually. We've done a little bit of work on this already. The deck, in fact, all the mechanical part up here, that actually went over to my friend Andy over at Vintage Electronics Repair, and he did a full service on that deck. It does still have a slightly noisy motor in it, which I might have to look at. But apart from that, the mechanism and everything works absolutely flawlessly on this player. And we went back into it and we did some work on the amplifier. Mainly we did the capacitors on the amplifier. But it still has the same issue. Mainly it's got very, very low output on it. I'll demonstrate. Now, whenever you're working on something like this and you've got like an issue like low output, either use a pre-recorded tape. I've got King and I here, so this shouldn't give us any copyright problems. Or at the very least, use a tape that you've made yourself on a known good working machine. Then you're not, chasing your own tail when it's actually a bad recording which is causing your issues rather than a fault with the machine, because I have been tripped up like that in the past. Anyway, I know this is a good recording because it's a test tape that I use quite a bit. And I know how it should sound on a good working machine. Let's put it on here and you can get an idea what the machine's actually doing. In fact, let's switch on. You can hear that slightly noisy motor. I'm going to have to do something about that. But we'll thread it up so it's not going to mess that up. Come on, in you go. There we go. So we're basically set up there. Getting a little bit of noise out of the amplifier then. But if I press play, forward it past the leader roll, and we'll press play. As you can hear, it does play. There's no distortion or anything, but that is absolutely top full volume. If I turn it down to what would be a normal listening volume, we get virtually nothing there. You can just hear a tiny little bit. So basically that's the issue with this machine. We've got low output. We'll stop that. Let's get that tape off. We'll switch off. So that's the issue that we've got. We've got low volume. Now we're going to use a couple of diagnostics for getting this thing hopefully working again. And it's basically very simple stuff. All we're going to use is test meter here. So basically ohms, volts, amps on there, although we very much doubt we're going to need the milliamp range or the amp range, but the ohms and the volts ranges we're going to be using. We're also going to be using these. What we've got here, these are that one's 1960s, that one's 1970s, and these are valve data books. These were produced by valve manufacturers. That's a Mullard one, that's a Mazda one. And basically what these have got in them is the characteristics for various valves. We'll look here. Let's try and find something that's going to be something similar to what will be in here. Well, anything, EC, let's see, there we go. ECC 83, we should find an ECC 83 tape recorder like this. And basically it'll give us what voltages we should have on the anodes, what voltages we'd have on the grids. It'll even give us what current or what milliamps we should be pulling on the anodes, things like that. And basically with that data and a meter, you can sort most issues on valve based equipment just by checking voltages on various parts of valves and tracing down the fault like that. There's other things we need to test in here as well. I can't remember whether I change the selenium rectifier in this for a silicon rectifier. It could just be as simple as the selenium rectifier has failed in it, and we've got very low HT, which would obviously give us that fault. So what we'll do, I'll pause the camera, I'll get this thing pulled out of the case and everything, get it set up on the bench, and then we can have a look. We can start at the basically we can start at the mains transformer, work our way through. We can test the selenium rectifier, make sure we've got a decent voltage coming out from there. If we have, we can carry on. If we haven't, we can rectify that and carry on. And then we can get to the valves, and so we can use the valve data books to make sure we've got some sensible voltages on the valves, and hopefully we can trace out the fault like that. Like I say, I'll get this out of the case, and we can crack right back on with it. So back in a sec. Right, okay, we are back. As you can see, I've got it all out on the bench here now. Now, what I've done, I actually took the speaker out of the case and left the speaker connected up there, so we've got some audio. But what I've done, I've actually disconnected the motor here, because obviously we've got it upside down like that. This motor won't spin properly in that orientation, so I don't want to risk burning the windings out in the motor or anything like that. So it was only 2 connections, so I've just unhooked the motor. That's not going to cause us any issues because it's the amplifier itself that we're going to be working on. As we can see, I mean, you can go back and watch my previous video on this. We have already recapped it, so we didn't change the main smoothing condenser there. Presumably, when we checked it out, it was absolutely fine. We've changed all the wax paper capacitors this would have had in it, and the Hunt's mold seal capacitors for modern polyester caps. We've changed any of the small electrolytics it would have had for, again, modern electrolytics. But I have noticed I didn't change the selenium rectifier, which is that thing there. That's what we need to look at first, because that very well could be our issue. So what we're going to do now, bear in mind, and I will, safety warning here, this is, mains derived electronics. It's high voltage, as in there is a few hundred volts DC on a lot of this circuit, and you've got mains over here. If you don't know what you're doing, obviously don't mess with this kind of stuff. I've been doing it for over 30 years, so I've kind of got a bit of experience of it. So obviously it's a safety aspect, and with that in mind, what I'll be doing, I've got my meter set up here. I've got my standard probe here, but I've replaced my other side just with a lead with a croc clip on the end, because for these first tests we can just literally connect one side to the chassis ground, and we can just use this one connection for taking our readings, which means we only need to use one hand. The other hand can stay in the pocket. It's an old rule that I was taught very, very, very long time ago by an old school electrician. Whenever you're doing diagnostics like this, whenever you're probing around, you only ever use the one hand. You always keep your other hand in your pocket, or sat on, or away from it. Because essentially, if you get a shock, say you're probing in here and you touch something with this hand, you go, ow, like that, and that'll be it. However, say I was holding the chassis like this, and I did exactly the same thing, I've now got a direct shot, a direct path from this hand, from the live there, right through my body, right through my heart, to the ground point there. That can kill you, and there's a very good chance that will kill you, because that's a straight shot right across your heart. Like I said, that hand's in your pocket, you're probing around, you touch your wire, you go ow, like that. It's as simple as that. It's something I've always kept with when I've been doing diagnostics. Right, so we will connect that to ground like that. Also bear in mind that this is an AC only set. Obviously it's got an induction motor, they only work on AC. It's got an isolating mains transformer. If you're working on a piece of equipment which uses the AC/DC principles, you've got to be even more careful, because you've got potential on that for the chassis to actually be at mains potential. On a set like this with a double wound mains transformer, that will always be ground. Right, anyway, so we've got our connection on there. We will plug in. I can't show this because this is slightly off shot, because I've had to it's still on the case, I've just had to push the case to the other side of the socket. Anyway, we've got power on there, so we've basically got mains. We've got mains to this now, so we're not going to be touching it. We'll switch the meter on, and we want a DC reading because we've got AC on this side of the selenium rectifier. Now I'm pretty sure that should be pretty close to what it should be, but we should have DC on this, basically on this wire here, and we want to see how much DC we've got coming off there. It should be over 200 volts. If it's under 200 volts, I think we've got an issue with the selenium rectifier. So we'll set the meter to the 500 volts DC range. Can you see that? I can't see. Right, if I turn that like that and I move that cable around there like that, you can see that now, can't you? Yeah, you can. So what we'll do, we'll switch on. Now, unlike a valve, that will give, these conduct instantly. So when we turn power on, there, we should now have our mains voltage, sorry, our rectified DC voltage on that point there straight away. Obviously, if it was a valve rectifier, you'd have to wait for that to warm up. So if we said one hand, this hand in the pocket, just one hand on the probe, and let's probe on there, and let's see what voltage we're getting out of there. And we're getting 226. Let's try that again. That doesn't look bad. That doesn't look bad at all. 220, yeah, 223. It's over the 200 volts, so I'd say that's working okay. The selenium rectifier is actually outputting fine there. Right, let's check some of the voltages coming off this main smoothing condenser, just to make sure we've got voltage coming off where we should have it. So we try on this section here, and this should have about the same on it. Yeah, 223. And then we'll check on the section which is after the current limiting resistor there. Let's check what's on there. About 169, 170 volts. Again, that should be absolutely fine, because that is after that surge limiting resistor there. So that voltage on that rail is always slightly lower. Right. So what we'll do, in fact, I will go and just grab a coffee, because my mouth is starting to dry up and I will start croaking in a second. And then we will start, I think, on the output valve. We'll actually work the other way around, so we'll work from the output valve back through to the preamp valve. We'll use the valve data books, and we will see what voltages we're getting on those valves, and hopefully there we will find one of the issues. So back in a sec. Right, okay, we're back. It's actually the following day. I don't know what it is, but every time I start filming a video, something comes up and I have to leave it. On the plus side, it does mean I got a call from the opticians, and my new glasses have come in, so at least I can see a little bit better now. So, where was we up to? We checked that we had HT. And we knew that we've got, even though we're still running on an old selenium rectifier, we still have a reasonable HT coming out of it there. Next thing we want to do, using the old valve data book here, is we're going to check some voltages on the actual valve. I think we'll start with the output valve, the ECL86, and then we'll move on to the ECC83 after that. Basically what we're going to do, we'll work from the speaker end back towards the power supply essentially. So first thing we're going to do is check the anode voltage on the output pentode. If you are familiar with the ECL86, it's basically got two valves in one valve base. So you've got a triode and a pentode, so basically a preamp valve and an output valve in the same glass envelope. So we'll check the output valve part of it first. We'll check the anode on that, make sure we've got some sensible voltages. We'll then go on, we'll check the triode section. And if we're happy about that and we can't find anything that looks too amiss there, we'll move on to the ECC83 and we'll do the same thing there. And like I said, there's a few other voltages we want to check as well, but those are really the first ones we want to have a really good look at. And then we can have a look at like the grid bias voltages and things like that. There's also a couple of voltages we want to check just for the safe side, like the audio output valve. There's a capacitor on the grid. Basically, it's a DC stopping capacitor on the grid of that valve. If that capacitor goes leaky, it can cause some issues, which basically damages the valve and can damage the output transformer. That's not going to be an issue on this particular set because we've already changed those suspect capacitors for these nice yellow polyester ones. So like I said, that's not really going to be an issue, but it's something we could check, and if we hadn't changed any of the capacitors in here, it's something that we'd be checking. Right, let's get this powered up. Now, what I have done, I'm still using my one hand for operating, one hand in pocket rule. I've connected the lamp limiter up. Purely, I've not actually got the lamp in series here, I've just got it off shot. The only reason I've done it is it means I've got a switch here, so I don't have to keep fiddling about under here turning it off and on, or reaching over there to turn it off and on. I can just switch off and on using the switch on the lamp limiter. So we'll power that up and switch on the test meter. Let's see, make sure that you can read that. Yeah, so you keep your eyes on that meter there. Right. Now the first thing we're going to do, like I said, is we're going to check the voltage on the anode of the ECL86 output. Oh, yeah, this book is very old and I'm losing pages out of it. I need to get some copy decks or something and stick them back in, or I'll end up losing them. These are, like I said, these are getting old, these now. So I think this one's from 1976. This is actually a later one. The other one I've got is from the 1960s. Right, so anyway, hopefully you can make this out. Can you see that there? Right, ECL86 is the valve that we're working on. And at the moment we're interested in the pentode section of it here. So if we look over here, we can see that the anode for the pentode is on that pin there, and that is pin 987, pin 6. So if we look basically where the gap is there, that's that is, I'll show you on the valve. Where's the valve? Where's the valve? There we go. Don't matter what I show. Oh, I've lost that again. Basically, if you look on the valve, you've got, this is a smaller valve, this is a 7 pin, but it doesn't really matter. You can see you've got a gap there between the pins on these particular types of valves. And you count from the base 1, 2, 3, 4, 5, 6, 7 round like that. Obviously this is a 9 pin valve, so it'd be 9, 8, 7, 6 like that. Put that away. This should have warmed up enough for us to get some sensible readings. I don't want to run it for too long, obviously, because we do definitely know we have got a bit of a fault. Right, let's check that anode voltage. So this is the pentode anode voltage, and we are there, and that's 1, 2, 3, sorry, 1, 2, 3, 7, that's that wire there. So I will touch on there, and we've got 156 volts there. Now that is a little on the low side. I'd have liked it to be closer to the 200, but I have seen a few sets that run like that, but it could be that we've got something actually pulling the HT down there. Let's see what our actual full HT is. Oh, well, our full HT is actually quite healthy. Yeah, 234, that's absolutely fine. So we are a little low there, but not terrible. Right, let's check the triode section of that valve. So again, we look at the chart here, and we're going to look round here, and we're looking for the anode for the triode, which is right down at the bottom there. So that is pin 9. So that's a nice easy one to find. So let's count round here, and that is pin 9 there with that capacitor coming off it and that resistor. So if I touch on there, and we've got about 100 volts there. That's a little on the low side again, but it's not terribly low, if you know what I mean. I'd expect it again. I expect that probably to be around about the 150 volts mark. So I think we might actually have something pulling the voltage down here. In fact, I have just noticed something as well. The current limiting resistor here. It's got some wax on it from the old wax paper capacitors, and it's actually melted. The wax is on the bottom of here and it's liquid. We've got liquid wax on the bottom of that. So that capacitor is that resistor is actually running quite hot. It's running hotter than you'd expect. These always run warm. They never run completely cold, but that's running hot enough that it's melted that wax that was stuck to it. So that is running probably a little bit too warm. Let's carry on with the anode tests anyway before we power back off and let that cool down. Now get the little book out. If we go back a page, and we've got the ECC83 here. It's also known as the 12AX7. That's the like most of the American designation for it. It is exactly the same valve. There is no difference. Right, so what we want to do, we've got two, it's two triodes in one envelope this, so again it's two valves in one, and they're both exactly the same triodes. So what we want to do is find the two anodes. So we've got an anode there on pin 1, and we've also got an anode there on pin 6, so those are the first two that we want to actually check. So we've got the valve base here. Let me try and figure out where pin 1 is. Where is pin 1? Right, that's pin 1 down there, so that's 1, 2, 3, 4, 5. I think that's 6 there. Oh, that's not right. That is not right at all. We've got far too low. That 37 volts, that should be well over 100 volts. Should be 150, 170 volts, that, not 37 volts. Let's have a look at the other anode, which is pin 1 we said, isn't it? No, pin 1 is, let me see now. That should be pin 1 there, I think. And again, we've got 39 volts there. That should be well over 100 volts. Let me just turn off. So we'll just make sure that this is safe. And what we will do, we've got the power off here. Let's just check on there. Make sure we've we've basically got no voltage there now. About 9 volts or so, just floating, just coming off the capacitor, I think. Yeah, about 10 volts there, just floating off the capacitor. That's not an issue. Right, so we've definitely got a fault, which is pulling the HT down. And one thing we could try doing, let's try pulling one of the valves out and see if that condition changes, because it could be we've got an internal short inside the valve, and that's pulling the HT down. So we'll start with the ECC83 here. We'll pull that out of circuit, and we'll just try measuring on them anode pins again with no valve in there, so there's nothing loading the circuit down, and check them voltage and see what we get there. We'll pop the retaining clip off. Let's get that valve. Now, it doesn't feel unduly warm or anything. It could be absolutely fine. That it could indeed be the other valve. Now, before we power it back up, we do have a retaining spring there. We've got to make sure that that's not going to short on anything and cause any problems. Because obviously without having the valve in there, it can float about, and there is a capacitor very close to it. I think that's going... It's touching it, but it's not actually going to short on anything, so I think we're going to be okay if we're just really careful with that. Right, let's power back up. Now obviously nothing's going to work because we've got the preamp stage pretty much disconnected. But let's see what voltage we have on there now. We'll look there. We've now got 150. That's more what I was expecting to find on there. Well, that is dropping quite rapidly. That seems to be stabilising there around about 100, 111 volts. Let's check the other one. Again, yeah. So it could be we've got a bad valve. We'll switch off. In fact, let me see if I've got a ECC83 that we can put in there for testing. I've got some tested valves here. And yeah, there we go. We've got a an ECC83, a 12AX7. And we'll try this as a test and see if it makes any difference. Valve wants to go in that way. Okay, that's the valve in. We'll put the retaining spring back on just so it can't short on anything. There we go. I'll have a quick slurp of coffee while I and power up. So we'll just give it a quick second just to for the voltages to stabilise, and we'll see what the voltage on that anode is. That's being pulled right down very quick, isn't it? So I don't think we've got a valve issue, because it's doing exactly the same thing with that valve in circuit as it was with the original. Slightly higher there, but it's still being pulled well down that. Again, let's switch off. We can also try the same thing with the output valve, because I think I've probably got some spare ECL86s. It'd be a shame if that's failed, because that's quite a pricey valve. So are these, to be honest. Anything that's used in high-end valve amplifiers or guitar amplifiers that are still used regularly, valve-wise, generally speaking, are getting quite pricey. You can buy certain valves brand new. They're still produced in China, I believe, but the quality of the valves you buy, which are modern manufacturer, are nothing compared with the valves that were made back in like the 1950s and 60s. They're far superior. Right, let us try. We're off there, so we're nice and safe again. Let us pull the ECL86 out. That is quite warm. It's not, in fact, that is very warm. Let's pull that out, and we'll do the same test again on the ECC83's anodes and see what our anode voltage is now with that valve removed. We're basically just eliminating both valves to make sure the valves aren't actually the issue. And then we could probably put that ECC83 back in there. Right, so again we will switch on. And again. are losing HT yet again. But if we check over here, we're showing it over 300. That's actually ridiculously high. Why is that so high? Oh, because we're not basically pulling anything down. We've got very little load on the circuit there. So that should be far higher. That should be far higher. Let me switch off there because we may actually be exceeding the yes. We're actually exceeding the maximum rating of the smoothing can there. That's only rated at 275 volts. So with the output valve removed, the HT is floating higher, and that could potentially damage that. So we'll make sure that's off now. Right, so I don't think we've got a valve fault. We've got a fault elsewhere in the circuit, which is not what I wanted to hear. It could possibly be the magic eye. There could be a fault with the magic eye. That could also be doing it. It's very unlikely, but really we do have to rule that out. So what I'm going to do, I'm going to actually take the magic eye valve there out of circuit, which is not going to be easy to do because it's really well buried in there. Let's see how we're going to get that out. There's 2 screws there to slacken them off. Oh, this is going to be fun. But we can't eliminate it being a valve issue until we actually eliminate all the valves. It's the least likely valve to actually cause a problem, but it can happen. So I wonder if one of them new precision screwdrivers I've got would help here. Right, that's that one out. Okay, that's one screw out. Let's see if I can retrieve that screw I dropped before. There we go, that's that one out. These are nicely magnetic. Right, let's see what we can do about releasing that magic eye now. Get hold of these and pull them out. There we go, that's one. That's 2 out. And let's pull the magic eye tube out, and then we've at least eliminated that as a possible problem. Oh, I think we do have a problem. That valve's no good. Let me get that valve out of circuit now. Very gently prise it off the base. That valve's cracked. That's gone down to air. There should be a getter somewhere usually off, off show on this side of the valve. The getter's completely gone on it. That's the indicator. That's basically what shows you your record level. That will glow like a phosphorescent green when these are actually working correctly. But if we look at the base there, I can see it's got a crack running right across the base all the way. So that's gone down to air. Right, I've got that out of the thing. We've got to make sure that that is not going to short on anything. Let's make sure that that valve base there is well out of harm's way. Nothing's going to short, because we're going to try powering this thing back up with that valve out of circuit, and we'll see whether that's made any difference. But we've definitely got a faulty valve there, as in it's actually physically cracked. And I will have to have a right hunt around to see if I've got any magic eye valves. In fact, it's got a crack. The crack runs all the way up. I can just see it now when I catch it in the light. The crack actually runs all the way up the envelope of the valve there. All the way along the bottom there to the base. Right, okay, let's I'm just got to double check that I've not got anything shorted where I've pulled that out. I think we're looking alright. So we'll switch back on. And we'll see if that was what was causing the issue. So if I go on here now. No, we've still got collapsing HT. Now I'll cut the power off because I'm running it without the ECL86 in circuit there. So we've got a fault where there is something pulling the HT down. So we could have a resistor which is drifting, which has drifted. Fine, let's see what the HT on that side of that resistor is once we... And this is why you have to be careful and you only use one hand. The power is actually off at the moment on here. So you can see that capacitor can still hold quite a charge. We've got 150 odd volts on that capacitor there. I put my... yeah, I've got well over 300 volts there. And switch off again. This might be one, I hate to say it, where I might have to see if I can find the circuit diagram for it. I don't think this is going to be quite a simple fix. We've gone through basically all the simple stuff it could possibly be. It's going to be something a little bit more complicated than that. So I'll tell you what I'll do. I'll pause this for now and I'll go and see if I can dig out the service data for this, which is going to be a bit tricky because I'm not 100% sure. That'll help. I've just noticed there's a date in the bottom of the cabinet, so we know the make of the tape recorder. It's a Defiant. We now know it was made in May 1962 because that's on the bottom of the cabinet, inside the bottom of the cabinet. I can go through my radio and TV servicing books for tape recorders from this manufacturer in 1962, and hopefully we can find exactly what this one is, and I can find a circuit diagram for it. So I will say back in a sec. Right, okay, we're back, and I've printed the circuit diagram out here. I've got the service notes for us as well, not that they're really very much good, but at least we know what the model is now. It's a model T12. It's a Defiant model T12 from 1962. But what we, like I said, what we do have is the schematic diagram here. There's not much, you know. The thing with the radio TV servicing books, the Molly and Poole books, is they don't give you quite as much information as like the trader sheets that were out there were. But they give you everything you really need. Like, so you get a circuit diagram and you get voltages on here. So we can have a look and see what this is saying we want for voltages, rather than just relying on the data from the valve data book, and to be honest, it's kind of the same, but this is exactly what was measured on one of the sets of the time. It even tells us voltage measurements using an AVO Model 8 input range 255 volts, selector in. Now I could go and pull my AVO out. I do have an AVO Model 8, but to be honest, we can get away with this. We can get away with a modern digital multimeter. It's just the AVO Model 8 is what they would have used back in the day when this was working on. But anyway, back to what I was saying. What I have noticed now, I started looking at some of the voltages on here, and I started having a bit of a prod round on the board, basically making sure I hadn't made any shorts when I actually changed the capacitors or anything. Although I don't expect that to be a problem, because we had this low volume from day one, from when I first got this reel-to-reel tape recorder. But what I have noticed, we've got a resistor there. Now that's smoked. It's not open. It's still reading, and I can still get voltage across it. But that has got very, very hot, and it's actually smoked in the middle there. It looks quite blackened in the middle. But here's the curious thing. I've currently got the ECL86 out. Now we've tried this already, but I've got the ECL86 out. If I power up now, and we go on the anodes of the ECC83. Now that was being pulled down to about 40 volts before. If I measure on there now, we've got 80 odd volts there now. Now the circuit diagram is saying we should have 75 there, so we are a little high. But bear in mind, we've not got any drain on the HT from the output pento, because we've got that completely out of circuit. But that's healthy. Let us try on the other side here. And again, oh, a little bit of there we go, 87. So what the hell's changed? That's looking about right. So what I think I'll do, let's switch off there. Let me just put a different ECL86 in. Let's see what we've got an ECL86 in here. We should have. Yeah, we've got a Mazda one there. A little more hard used than the valve that's out of this, so I hope that valve's not faulty. But let us see what happens if I put this in circuit now, and we're off there. In fact, I'll have to just fiddle about here because I can't quite see that valve holder. There we go, I can see it now. Right, we've stuffed a... all these valves that I'm using are tested. They have been through on my AVO valve tester at some point. I just keep them in that box because the valves that I use fairly often. So I keep think something like an ECC83 in there, I keep an EZ80 in there, EL84, ECL86. All the valves, like I said, that I use quite often, basically. Right, so we've put the a known good ECL86 in there. Let's power back up and let's see if the faults come back. In which case it's still something in the circuitry, or it was either the valve was iffy, or just me moving stuff around. Something must have been shorted and I've cleared it just by moving components about. So anyway, let's power back on. We'll get our probe. And again, we're going to measure on the anodes of the ECC83 because we know we should be getting around about 75 volts there for the anode voltage. Now it will be a little bit higher at first. 61, that's a bit low. But we seem a lot healthier, a lot happier than we were. You can hear that from the what's coming out of the speaker. Let's try the other one. $57. So it's a little low, that it should be closer to 75. But we seem to have a lot more life there. In fact, I can hear a hiss from the speaker now, which I couldn't hear before. We've actually got some life out of that speaker now. Weird. Let's check some of the voltages here now. Let's see what we've got coming off the rectifier. We could still have a slightly iffy selenium stack here as well. See what we've got pulling off there. We've got 237 coming off the selenium stack rectifier there. And according to the valve data we've got here, that should be 200. That should be 280 volts coming straight off the selenium stack there. We've got 237. So I think we do actually have a slightly tired selenium stack rectifier. I think it is starting to go that, because it's got a lower output voltage than it should really have, and that'll pull all the other voltages down basically. But that's sounding a lot better. I can hear things coming out of that speaker now. Right, we switch off. I don't know the problem is, we know one fault. We know we've got a bad EM84, so I'm going to have to find a new replacement EM84 for this, which I'm not sure. I think I've got some kicking about somewhere. That I'm not majorly concerned about, to be honest. The tape recorder should work absolutely fine without it, as far as I'm aware. Especially for what I want to use it for, which is just playing back tapes. I don't want to bother. I don't need it for recording or anything. And this is basically all it's used on the tape recorder is a record level indicator. It, like I say, it goes up on there. So without it, I'm pretty certain that at least the playback functions on this should still work absolutely fine. Anyway, I'm going to throw the original ECL86 back in. Make sure everything's off. Yeah, we're safe there. And about the orientation. And let us see whether the fault comes back with this valve in. If the fault comes back with this valve in, we can be pretty certain that it's the valve that's at fault. If it doesn't and it works now, the only thing I can think of is that we had a slight short here, something was touching, and me just moving a few components around while I was just checking out and tracing out some circuits on this, and doing that's cleared it. So let's have a go. In fact, that's there. I'll switch power on. Let's get the meter in situ. We'll do some tests again. Let's just see what we've got here. That's hot. Right, let's try and see what we've got at the anodes over here. Right, and it's gone. Oh, how weird's that? So is that valve flashing over? Is that valve failing as it warms up? Let's turn off again. I wonder if that's the issue. I wonder if that valve's got an internal short, and as it warms up, it's starting to basically short out, and that's what's pulling the HT down. That is a possibility. And I have seen valves fail like that before. Let's swap back to this one. and we'll see if the fault comes back. If the fault stays away, it's the valve. If the fault comes back, it's not the valve. Well, it's probably not the valve. Let's get you back in there. We'll power back up. And we will check on here again. They should drop right off as the rest of the valves warm up. Well, I say we're looking for around about 59-60 volts. We obviously know we have got a bit of a tired selenium rectifier. And we're back there, we've got about 60 volts, 59 volts. But we're still running. Yeah, stabilised around 56 volts there. If you can make that out. There we go, you can see that now. And we'll check on this anode. Yeah, about the same. So all our voltages are a little bit low because that it looks like that is starting to go. But it should actually work for the time being. Right. What I will do, we're not finished with this tape recorder yet. Obviously that is going to need replacing. I'm going to have to find a replacement for that. And we're going to have to change that selenium stack for a modern replacement, a silicon replacement. But for the time being, what I'm going to try, I'm actually going to put the tape recorder back together and let's actually see how it plays, and then we can take it from there. If it all plays nicely now, we know what our issue is. We know that the main fault was caused by that valve there. Could perhaps even test that. So we know that that's the fault, and like I said, we can go back in this, we can replace the magic eye, and we can replace that selenium stack. So just bear with me a second while I get this thing put back together, and then we can test it out and take it from there. So back in a sec. Right, as you can see, we're all back together, well, apart from the faulty valve and the two brackets and the screws that hold it. I'll put all that in a little bag. And you can just go inside until I find a new EM84. It is the EM84, yes. So I do think I might most likely have some of those kicking about. It's just a case of locating them. Right, anyway, we'll power back up. Switch off, do it properly. We'll put the power in. Let's get a take-up reel. And yes, I have reconnected the motor to the thing. I did that off camera quickly, so we are definitely going to get a rotation on the motors. We will put the King and I on. This should be old enough from what I've gathered to not get us a copyright strike, so that's why I'm using the King and I. I've got some Gilbert and Sullivan as well. So actually exactly the same as what I use for testing record players and demonstrating record players, which again, there should be no copyright on now. Right, okay, let's switch on. We have got power on, haven't we? Right, well obviously we have to leave it a little second for it to warm up, and we'll power up. Oh, it helps if I switch on. It helps if I switch on, doesn't it? There we go, we're on. So again, we'll just give it a little second just for the valves to warm up. Turn the volume down a bit. Let's give it a start. Just let it get off the leader tape. Now that's louder already than we had it full volume. were getting no more volume than that before. That was basically max volume where I've got it there. Now, excellent. Rewind that. Brilliant, so that seems to be working now. It looks like it was all down to a faulty valve. Now, if you want, when I do the next video on this, if people shout out and they want to see me actually test this, I'll stick it in the drawer and mark it up as bad, and we can pull the CT160 out and we can actually put it on the CT160 and see why it's failed. It can tell us whether there's heater cathode short, whether, you know, basically what's wrong with the valve, using the valve tester. But I'm quite pleased with that. We've certainly at least found what the fault was. We mightn't have used all the diagnostics to, you know, ideas to the full advantage there, but at least we know that really we do need to change that selenium rectifier. It is a little bit low. We could find out, you know, basically where we had an issue, that we had low HT. This was leading us a little bit of a merry dance, because it seems to warm up okay, and then once it's warmed up, it dies. So there's obviously some thermal issue with that valve. Anyway, I'm going to leave it there for now. Like I said, there will be a final video on this when we replace the selenium stack and give it a final finish off. But what I'm going to be using this for, it's in a workable state now. And I've got that massive, great big box of tapes kicking about here that I got from that chap that I got that Grundig off, that I passed on to Steve. It's all folk music recorded off the BBC in the 1960s, and I'm quite intrigued to see what's on them tapes, and they should play on this machine fine. So I'm going to have this playing on in the background while I'm doing other things in here, playing through them tapes, and it can get a bit of a use and see whether it comes up with any other faults. And if not, like I said, we'll get a new EM34 for it, get that in there and get this finished off. So anyway, I'm going to leave it there for now. I hope you enjoyed this little video on this Defiant T12. So I will say thanks for watching and goodbye.